Hello friends, myself R.D. Mahajan presenting my video on Z transform. In this video I will discuss some standard results of Z transform. The first one, prove that Z transform of A raised to n is equal to Z upon Z minus A for the condition n greater than or equal to 0. And as the condition is n greater than or equals to 0, we know that Z transform of that function f of n is obtained by formula summation from n equal to 0 to infinity f of n into z raised to minus n, and therefore z transform of that function a raised to n summation from n equal to 0 to infinity f of n is a raised to n. We substitute that function here into z raised to minus n. Combining that power n, we get a z raised to minus 1 whole raised to n. N changes from 0 to infinity. This is summation of a by z, transferring that z raised to minus 1 to denominator, and that bracket raised to n, and n changes from 0 to infinity. Substituting values for n equal to 0, we get n number raised to 0 1 first term. For n equal to 1, we get a by z. Next one, a by z whole square. Next, a by z cube, and so on. Then, as I had discussed in earlier my first video on Z transform, sum of this term 1 plus capital X plus capital X square plus capital X cube, that sum is nothing but 1 upon 1 minus capital X, and that capital X is here a by z, and the condition is mod of a by z less than 1, and therefore we get the result. Simplifying it by cross multiplying, we get z upon z minus e with the condition mod z greater than mod of e. This is z transform of a raised to n. And after deriving this result, remember this as a standard result. The first standard result is z transform of a raised to n is z upon z minus e. Means we can apply this result to get z transform of such type of term. Second example, prove that z transform of u of n, it is unit step function as z upon z minus 1, condition mod z greater than 1. First of all, I will define that term u of n. With the help of the figure, on x-axis we take the values of n, and on y-axis we take the values of f of n. This is a figure representing that unit step function. Value is 1 for n greater than or equal to 0, and for negative values, value is 0. This is the definition of that unit step function. And after defining that term, we try to find out z transform of that unit step function. As it exists for greater than or equal to 0 values only, we use that second result, z of f of n, as summation from n equal to 0 to infinity f of n into z raised to minus n. And therefore Z transform of unit step function u of n is equal to, function is u of n into z raised to minus n equal to 0 to infinity. Then in that range value is 1 here. And therefore that summation becomes 1 multiplied by z raised to minus n changes from 0 to infinity. And that z raised to minus n we can rewrite as 1 by z raised to minus 1 and that raised to n as 1 by z whole raised to n. Substituting the values, for n equal to 0 we get first term as 1. For n equal to 2 we get that term as 1 by z. For n equal to 2 we get 1 by z whole square. For n equal to 3 we have 1 by z cube and so on. And again applying binomial theorem, sum of this type of term is nothing but 1 upon 1 minus capital X, the value of capital X is here 1 by z, and the condition is mod of 1 by z less than 1, and therefore we get z transform of that unit step function as cross multiplying it by z, we get z upon z minus 1 as a required z transform or answer, and the condition is mod of z greater than 1. We get the required result. Hence proved. In my next video, I will discuss the remaining standard results of Z transform. If you like my video, please share it as well as subscribe to my channel, and to receive the notification for my new videos, press the bell icon. Thank you. Thanks for watching.